Hi everyone, Mrs. Musoff here. Today we're going to be talking about right triangle trigonometry as it applies to word problems. Alright, and there are a few key definitions that we have to make sure we know. The first one is the angle of elevation. And notice how we are talking about an angle, so it's going to go in the corner. Alright, the angle of elevation is always going to be inside of our triangle, and it should always be at the bottom. Okay, and it's labeled in the picture right here. Okay, obviously not going to be our right angle, so not right angle. But it'll be your other angle that's at the bottom. Okay, inside your triangle at the bottom. The angle of depression, still an angle, but depression, the idea to get is that it's going down, so it's as if you looked straight ahead and then looked down. It's that angle. Okay, this angle will always be outside of your triangle and on the top. Okay, and you can see it in this picture right here, right? It's this angle right there. But wait, one thing some of us might remember from geometry is that if we have two parallel lines, 1, 2, then these two angles, this one that's labeled x, as well as the angle labeled x from the previous picture, they're actually equal to each other. So the angle of depression and the angle of elevation are always going to be the same angle. So let's take a look back at these pictures again. If we know that they're the same angle, erase all these marks. If you know that they're the same angle, which of these two labels do you think is going to help us the most when it comes to solving for a piece of the triangle? Hopefully you said the one inside your triangle. Alright, we always want to try and label it inside, because that way we can actually use it. When it's outside, we can't. So since we know that they are equal to each other, we're going to always label this angle in that bottom inside corner. Alright. Now the big thing with word problems, because I know everyone always hears word problems and it's like, those are so hard. And they are kind of challenging, but I will say the students who do not draw and label the situations are the ones who don't do well. And when we say draw and label, I don't mean just draw a triangle and label opposite, adjacent, hypotenuse, but label it with words from the situation. That way you can be sure that your triangle looks right. Right? Like if you label it and the ground is up in the air, then something's wrong. Alright, so label it with words, that way your triangle will make sense and you'll be able to solve it. Okay, so let's try a couple examples. For these it says draw and label a picture for each problem and then solve round to the nearest tenth. So we've got a plane begins descending in a straight line toward a runway. So descending means it's going down. So if it helps, I'm going to go ahead and draw a plane, or at least close to a plane. Sorry, not a good drawer. Not a good artist, I should say. But it begins descending in a straight line toward a runway, so something like that. And hopefully just by drawing that line, you can start to see what kind of triangle we're making. Okay, it's descending towards the runway, so this part of my triangle, right, this could be like the ground or the runway. Ground/runway. And if you're an artist, you could even get a little creative with how you draw it, right? Maybe you want to draw it like an actual runway here. Go for it. Okay, and then once you've got a couple of the sides figured out, turn it into a right triangle, because every time we do this, we want a right triangle. Okay, so I've got a plane. It's descending in a straight line. The straight line is that toward a runway. It says the length of that straight line to the runway is 60,000 feet. So that's this side right here, the straight line side. 60,000 feet. The plane is 45,000 feet in the air. Now, 45,000 feet, we know that that's going to be another side. So all you have to ask yourself is, which side would that make sense? If it says it's 45,000 feet in the air, well, this side, the one that we labeled ground runway, that's not in the air. That's on the ground. All right, so 45,000 feet in the air is going to be our vertical side. And then the question is, what angle of depression must the plane use to reach the runway? All right, now angle of depression, remember we talked about it up above. Technically that's going to be, if I were to have a side here, it would be this angle. I'll call it x. Okay, but that angle does us no good because it's not even in the triangle that we drew. So remember, angle of depression is equal to the angle of elevation, so we're going to just relabel it as this angle down here in the bottom. And now this should be a triangle that we are somewhat familiar with, and we should be able to solve it the same way we've been solving before. We're going to circle our reference angle. I'm going to label opposite, hypotenuse, and adjacent. And then using SOHCAHTOA, I should be able to set up a trig equation and solve. Alright, the trig equation, I'm going to use my highlighter to help me out. I know this side, that's opposite. I know this side over here, that's hypotenuse. Opposite and hypotenuse is sine. And remember, the equations always go sine of our angle, x, is going to equal opposite, so 45,000. Divided by hypotenuse, which is 60,000. All right. When it comes to solving for your angle, remember that's when we use inverse trig on both sides. One side will undo itself. The other side we're going to throw in our calculator. And to type this in to our calculator, don't forget that that means you need to press second and then sine. All right, so I'll do it real quick for you. So it'll be second sine, that's inverse, of 45,000 divided by 60,000. Close it up, press enter. And there we have it, said round to the 10th, so this 9 is going to make my 5 bump up, so 48.6 degrees. There we go, 48.6. And degree sign, because it's an angle, so we need to have the degrees. Okay. The big thing with word problems is going to be remembering your units. So angles are nice and easy. It's just a degree sign. Sides we got to get a little more careful with. Okay. So a few more examples. We're going to move a little quicker here. Number 2, Humpty Dumpty is sitting on a wall. So first sentence, and I can already get a little bit of a picture going. Here's like the side of the wall, and here's Humpty Dumpty sitting on it. Or standing, I guess, but you get the point. If the king's people want to rescue Humpty before he has a great fall, how far from the base of the wall? Base, remember, means bottom. So how far from the bottom? So I'm going to draw a side from the bottom. Should they place the base of their 50-foot ladder? Gotcha. So we have a ladder forming right here. And I'm going to draw it like a ladder, or at least somewhat like a ladder, so that I get the picture here. If you're not a good artist like me, it might help you to label some things. Ladder, ground, wall, just so we don't forget. So how far should they place their 50-foot ladder if the ladder makes a 55-degree angle with the wall? Well, now that I've got my picture taken care of, I can start putting some numbers in. It says the ladder is 50 feet tall. 50-foot ladder, right? That means the ladder's 50 feet. So right here I can label 50 feet. It says the ladder makes a 55-degree angle with the wall. So the angle between the ladder and the wall is 55 degrees. Well, that's up here. All right, between the ladder and the wall, that's this angle. That's why it helps to label. And then let's make sure we understand what we're solving for. The question said how far from the base or the bottom of the wall should they place? And so how far from the bottom? That's going to be the bottom side. So this right here is going to be x. All right, and then I can start the same process we're used to. Circle my reference angle, label opposite, hypotenuse, adjacent. Using SOHCAHTOA, we can figure out which trig function to pick. Well, I know the ladder is 50 feet, that's my hypotenuse. And I'm solving for x, the ground, that's my opposite. So opposite, hypotenuse. Looks like we're doing sine again. Okay, so we'll write sine of our angle equals opposite, that's x, divided by hypotenuse. Now here we're solving for a side, so it works a little different. We don't use inverse. Instead, we multiply by what's on the bottom of our fraction. One side undoes. The other side we'll throw in our calculator. So let me clear out the last one. 50 times the sine of 55 degrees. And if you're getting different numbers than me, check that you're in degree mode. Remember, press the mode button and it'll tell you. All right, nearest tenth, so this 5 actually bumps the 9 up, and it bumps the 0 up. That makes it 41. So this will be, x will be 41, or 41.0. And then remember, this is not an angle, this is a side. Sides should all have the same units. So since this unit was feet, this unit will be feet as well. And there's my answer. All right, let's try another one. Number 3, it says, a squirrel is 18 feet from a tree. All right, so we've got a tree, something like that going on. All right, that's maybe the vertical side of our triangle, and then there's a squirrel over here. Ooh, a squirrel, I don't think I can draw that one as well. I'm just going to draw an animal with a tail. And eyes, there we go. Squirrel. 18 feet from a tree, so that means this side is 18 feet. From the top of the tree, the angle of depression to the squirrel is 41 degrees. Well, remember, the angle of depression, I can go ahead and draw this triangle here. Angle of depression is always going to be this angle. But since that's not in the triangle, we're going to use the angle of elevation. So this angle right here, we're going to call the angle of elevation, which is the angle of depression, and that's 41 degrees. And then it says find the height of the tree. Well, the height, that's vertical, okay? Height is always vertical. So that'll be this side over here. So once again, I can set up my SOHCAHTOA. I've got my angle circled, opposite, hypotenuse, adjacent. And once again, using SOHCAHTOA, I should be able to figure out my trig equation. All right, I'm solving for opposite. I know adjacent, opposite and adjacent. That's tangent. So I'll write my equation. Tangent of my angle, 41 degrees, equals opposite, that's x, divided by adjacent, which is 18. Once again, solving for a side, we don't use inverse trig. Instead, we look at what's on the denominator here, and we multiply it. And on one side, they undo each other. On the other side, we go to our calculator. 18 times the tangent of 41 degrees. So 15.6. And again, since this is a side, it's not degrees. I'm going to look at this side. This was in feet. So this side will be in feet also. And that's how high the tree is, how tall the tree is. All right, one more. I'm going to set it up, and then I want you to try and pause the video, see if you can finish solving it, and then you can check your answer when you're done. Okay, so a new store is being built. An escalator is planned. Remember, escalator, it's moving stairs. Okay, that's what an escalator is. So we can kind of draw a picture here, maybe, if you really want to get, right, something like that. So we've got, now we drew it like stairs, but remember, we're imagining this is actually just a normal triangle. Okay, normal right triangle. It says the vertical up-down distance between floors is 14 feet, so that's my vertical side. And the escalator will be 26 feet long. Well, remember, this side, if you need to write it, go ahead, but this side is my escalator. So when it says it's 26 feet long, that's talking about the hypotenuse. And then our question is, what is the angle of elevation? Once again, remember, angle of elevation is always inside and at the bottom. So right there is my angle of elevation. Take a second now. Try to pause the video. Remember, the next step would be to label. Circle your reference angle and label. So pause the video. See if you can finish solving this on your own. And then unpause when you're done and you can check your answer. All right, you unpause, take a look at your answer. It should be 32.6, and notice how there's a degree sign because it's an angle. If you're not sure how we got that, take a look at my work, right? I circled my angle, labeled opposite, hypotenuse, adjacent, and that told me, based on the 14 and the 26, that I wanted to use sine. Since it was an angle, I used inverse sine, second sine, and that's where my answer came from. All right, so you've seen a bunch of examples. If you have any questions, just make sure you write them down and ask your teacher in class. Thanks for watching.